Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Pathucheto Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area, energy and change. The topic is static electricity, and the subtopic, which is our main area of focus, is friction and static electricity. Let's look at today's lesson objectives. By the end of today's lesson, you should be able to recap on the structure of an atom, explain what a neutral atom is, and define static electricity. Explain how a material becomes electrically charged. Define friction. Describe electrostatic discharge, and investigate static electricity. All of this is on your CAPS document on page 47 to 48. Let's look at pre-knowledge. In grade 5 and grade 6, you learned about circuits and current electricity. This has been the foundation for today's lesson. Let's look at today's baseline activity. We're going to be focusing on atoms. Study the diagram below and then answer the questions. So everything is going to be on that diagram. Okay, how many electrons does this atom have? How many electrons does this atom have? And then this atom has 6 electrons. Why am I saying 6? Because we are looking at the electrons, and the key for the electrons is the green circle. It is the green circle, so that is our key for the electrons. It is the green circle. And then we have 1, 2, 3, 4, 5, 6. We have 6 electrons. So those are the number of electrons that we have. And then number 2, what is the atomic number of the atom? What is the atomic number of the atom? Look at the diagram. Focus on the diagram, and then tell us what the atomic number of the atom is. Don't forget to send in your answers to 079 576 2908. So the atomic number is 6. Why am I saying 6? Do you remember from the previous term when we were defining atomic number? The atomic number represents the number of protons that are in the nucleus of that particular atom. So it represents the number of atoms that are in the number of protons that are in the atom. And here we have our key. We have 6 protons. So the atomic number is the number of protons. So this is why the atomic number is 6. And then the next question. What is the charge of this atom? Explain your answer. What is the charge for this atom? Explain your answer. Look at that diagram and figure out what the charge is. Don't forget to send in your answers to 079 5782908. 5782908. Okay, so what is the charge? The charge is neutral. Why am I saying the charge is neutral? Remember in the previous term when we're learning about the structure of the atom, we learned that the atom has subatomic particles, 3 of them. We have electrons, we have protons, and we have neutrons. Well, now electrons have what we call a negative charge. This is why there's this minus sign inside the green circle. And then protons have a positive charge. That's why there's a plus sign on the blue circle. So if there are equal numbers of protons, 6, and equal numbers of electrons, which are also 6, which means that our charges are balanced. We have 6 negative charge and 6 positive charge, so our charge is balanced, which means our overall charge is going to be neutral. So the charge of the atom is neutral because the number of electrons is always equal to the number of protons, therefore the atom is electrically neutral. So I'm going to give you 1 minute to copy down the corrections, and then we will continue with our lesson. had enough time to copy down the corrections. Let's move on to terminology. So these are important terms that we're going to be using during the course of the lesson. You'll even come across these terms during the course of the term. So let's see what terms we have. We have friction. We have friction. What is friction? Friction is the force that opposes the relative motion between two surfaces of objects when they come into contact. When they come into contact. The second term is electric charge. Electric charge, it is the positive or negative property of a particle. So now we know that particles can carry charge. They can carry charge. And then static electricity, which is part of our topic, it is an electrical charge caused by the build-up of electric charges on the surface of an insulator of electricity. We've got more terms. And then attract. What is to attract? To attract is to make something move towards another thing. And what is to repel? To repel is to push away from something. And then an insulator. An insulator is a material that does not allow a charge to flow through it. And then neutral. A neutral object is one that has the same number of positive and negative charges. Remember from our baseline activity, we said that that particular atom in the diagram had a neutral charge. This is because it had the same number of protons and the same number of electrons. So we said it has a neutral charge. And then electric discharge. It is the release of electric charge through a solid, a liquid, or a gas. So we're talking about different materials in different phases here. Now, let's talk about the structure of an atom. Do you remember from the previous term? So atoms are made up of subatomic particles. Before I pull up the name, do you remember the names of the subatomic particles? I'm sure you do. The first ones are protons. These are the positively charged protons. These are found in the nucleus of an atom. And then we have neutrons. These are also found in the nucleus of the atom. They are tightly packed in there together with the protons. And then we have negatively charged electrons. These are found orbiting freely around the nucleus. So we know that within the nucleus we've got protons and we've got neutrons, and then outside of the nucleus, this is where we find your electrons orbiting around. There is our atom. It's the same one we had for our baseline activity. So we've got the electrons orbiting around the nucleus. So this part here, this is our nucleus. And inside the nucleus, this is where we find protons and neutrons. Okay, so this is where we find little protons and neutrons within the nucleus. All right. Now, so this is the neutral atom. Why am I saying it's a neutral atom? Because it has equal number of negatively charged and positively charged particles. So the charges balance each other. There's no one that is more than the other. Now let's talk about friction. We have defined friction in our terminology slide. But let's talk deeper about friction. Friction, it is the force that opposes the relative motion between two surfaces of objects when they come into contact. Imagine yourself stepping on the floor and you're walking towards the door or you're walking towards your classroom board right now. There is some friction that is happening because we have two surfaces. We have the surface of the floor and we have the surface of your shoe. So these two objects, when they come into contact with each other, there is a force that's going to oppose you going to the front. You going forwards, there's always going to be a force that's going to oppose that. So now friction between two objects causes electrons to move from one object to another. Remember, all matter is made up of particles, and those particles are atoms whether those atoms are within molecules or whether they are within compounds, but those particles are atoms. And remember, atoms have electrons. So friction between objects causes the loss of electrons from one object and is going to move to another. Look at that video that I've just pulled up. We have the two hands. One hand is holding the ruler, the other hand is holding the cloth. So the cloth is being rubbed on top of the white ruler. As the person is rubbing the cloth on the white ruler, there is electrons moving from one object to another. And then the object that gains electrons becomes negatively charged because now it has more electrons than protons. For an object to be said it is neutral, it is not charged, it has to have the same number of protons and the same number of electrons. Now, so the object that loses electrons becomes positively charged because now it has fewer electrons. So let's go over this again. The object that gains electrons, so it is gaining electrons from another object, it becomes negatively charged because it has more electrons than protons. And then the object that loses electrons becomes positively charged because it has more protons than electrons. So that is the result of friction. Now let's talk static electricity. I'm sure you have experienced it and you just don't know it. Now let's learn about static electricity. So electrons are never created or destroyed. They can only be transferred from one object to another. So electrons are not created nor destroyed. They just move from one object to another. Now that we know that the number of electrons that one object loses is the same number of electrons that the other object gains. Let's say you are rubbing two objects together. Remember I said electrons move from one object to another. And we have two electrons moving from, let's say we're rubbing this pen on my jersey like this. And then electrons are moving from my jersey to the pen. If my jersey loses 2 electrons, it means that the pen gains 2 electrons because electrons are not created nor destroyed. So now insulators are capable of becoming charged through the process of friction. Because they cannot conduct electricity, they can hold a charge, but they can hold a charge. Now, remember when we're learning about properties of metals and non-metals, we said non-metals do not conduct electricity. Now, however, non-metals, or rather insulators, like my woolen jersey here, it cannot conduct electricity, but it can hold a charge. This is because of the transference of electrons. If there happens to be any friction between my sweater and another object, it can become electrically charged and hold that charge. Let's look at this diagram that I just pulled up. So we've got object A and we've got object B. Let's count how many protons and how many electrons each object has, so we can determine if they are neutral or they are charged. So we've got 1, 2, 3, 4, 5, 6 electrons. So we've got 6 electrons. I'm going to write the letter E there. And then we've got 1, 2, 3, 4, 5, 6 protons. We've got 6 protons. I'm going to write the letter P. Let's count for object B as well. 1, 2, 3, 4, 5, 6. 6 electrons as well. And 1, 2, 3, 4, 5, 6. 6 protons. So object A and object B are both neutral. They have balanced charges. Both of them have 6 electrons and 6 protons, and 6 electrons and 6 protons. If, however, we happen to rub object A and object B together, and we have a bit of friction between the two. Then there's going to be some transference of electrons. So let's find out which object loses electrons. So now we've got 1, 2, 3 electrons for object E or for object A, which means object A has lost electrons. And then we've got 1, 2, 3, 4, 5, 6 protons, and object A has 3 electrons and 6 protons. So now what is the overall charge for object A? It is positive because it has more protons than electrons. Protons don't move. Protons are not transferred, they don't leave the nucleus. Only electrons move. So when the electrons move, that's when the charge changes. So now that we've lost electrons, now object A has become positively charged. Now we have over here 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. And 1, 2, 3, 4, 5, 6 protons. So we have more electrons than protons in object B, which means object B is now negatively charged because it has more negatives than positive charges. It has more negative charges than positive charges. Now let's look deeper into static electricity. So the imbalance, now because there's an imbalance, remember there were 6 electrons and 6 protons in both object A and B. But after there was friction, after friction happened, we ended up with an imbalance. That imbalance between the negative and the positive charges is now called static electricity. It is now called static electricity, that imbalance. Remember, I'm sure you've had an incident where you've held a doorknob or a water tap and then you felt some kind of shock. That is static electricity because of the imbalance in positive and negative charges inside an atom, resulting in the object becoming charged. Now, if we take, for example, a ruler and a soft cloth, if you've got a ruler there with you in the classroom, you can grab your ruler or you can use your uniform or your jersey as the soft cloth. Now, so the ruler and the cloth, they are neutral as they are right now. They are neutral, which means they have equal numbers of positive and negative charges. Remember, when we talk charges, we're talking electrons. They have the same number. Okay, so when the ruler is rubbed against the soft cloth, there is a force of friction. There is a force of friction between the ruler and the soft cloth. There is a force of friction between the ruler and the soft cloth. Now, the soft cloth resists the movement of the ruler. Remember, we said it's a force that resists. Remember, we defined friction as some kind of resistance. It's opposing motion. So there is a friction. Now, look at the soft cloth and the ruler. As you are rubbing it back and forth, whichever direction you want to use, there's going to be friction. Now, there's going to be friction. So the friction now causes the outer electrons of atoms of the soft cloth to be transferred. Remember, we said electrons are found in energy levels. The first energy level can hold 2 electrons. The second energy level can hold 8. So the electrons that are on the outermost shell are the ones that are more prone to be lost because they are further away from the nucleus. So now the outer electrons of atoms of the soft cloth can be transferred to the ruler. They can be transferred to the ruler. The protons don't move. They do not move. Protons do not move because they are tightly held in the nucleus. So now the soft cloth loses electrons. It loses electrons, which causes a positive charge on its surface as it has fewer electrons than protons. As long as there's an imbalance, if we have more or less of the other, then the object becomes charged. So it is up to us to find out what the charge is. So the ruler gains electrons. Now that the ruler has gained electrons, this causes a negative charge on its surface because now it has more electrons than protons. So it has more electrons than protons. There is our ruler and cloth again. Now, so the number of electrons that are on this soft cloth that is lost. Let's focus on that word lost. Is equal to the number of electrons that the ruler gains. So when the ruler gains electrons, the number of electrons, let's say it gained 5, which means the soft cloth lost 5. Remember, electrons are neither created nor destroyed. So both the soft cloth and the ruler are insulators and cannot conduct electricity. The charges remain static on their surfaces, and the negative buildup on the surface of the ruler remains static. Through friction, we can charge materials such as plastic, glass, nylon, and wool. You can charge insulators through the process of friction. All right, so let's look at this activity. I've got an activity for you, activity 1. The first question is, how do electrons move from one object to another? What is static electricity? What charges move when objects are rubbed against each other? What is the electric charge of an object that loses electrons? I'm going to give you 5 minutes to answer these questions. And please send in your answers to 079 That is our WhatsApp number. I'll be waiting for your responses. Welcome back. I see the responses are coming in. We have a learner from Tutolipa who just sent in their responses. We'll read the responses at the end of the lesson. Thank you for sending your responses. Now, let's answer the questions. How do electrons move from one object to another? Electrons move from one object to another through friction. Through friction. And what is static electricity? It is the electrical charge caused by the build-up of electric charges on the surface of the insulator. On the surface of the insulator. And what charges move when objects are rubbed against each other? It is the negative charges. Remember, it's only the electrons that move. The protons are tightly packed in the nucleus, so they do not move. So it's the only charge that moves when two objects are rubbed against each other is the negative charge, the one that moves. So what is the electric charge of an object that loses electrons? What is it? It will be positively charged because it would have lost its negative charge, leading to it having more positive charges than negative charges. Continue sending in your responses. Don't forget to mention the name of your school. What is the effect of charged objects on each other? What is the effect of charged objects on each other? So now an object, we have said, becomes electrically charged when it is rubbed against another object. So that is through friction. We've said that already. No, we know that already. We know that already. So now, when an object is charged, it is either positive or negative. It is either positive or negative. So a charged object influences other charged or neutral objects. So let's find out how they are influenced. Now, so the objects that have different electric charges attract each other because they move closer to each other. I'm sure you have experienced this. Let's say you're putting on whether it's a shirt or it's a dress. And then it keeps on sticking to your body. Or girls, you're wearing a skirt and then that skirt keeps on sticking onto your body. Why is that? Have you ever wondered why it is so? This is because when an object is charged, it becomes attracted to other objects, be they whether they are charged or they are neutral. They move closer to each other. They move closer to each other. Let's go back to that picture that we had before where we had object A and object B. If you remember the resultant after losing electrons, object B ended up with 3 electrons and 6 protons. Object B had 9 electrons and 6 protons. Now, these two, as you can see, they are now close to each other, whereas we say they are attracted to each other. But why is it so? What brings them together? What brings them together is the different charges. We said these ones are positive and these ones are negative. So object A is negatively charged and object B is positively charged. So now the different charges. Now, a charged object influences another charged object. So this one is positively charged and this one is negatively charged. So negative and positive are opposites and opposites attract. So that's why you're seeing the two objects are now attached to each other because the negatively charged object and the positively charged object are now attracted to each other. They are now attracted to each other. So that is what happens when your skirt sticks to your legs. Now, objects with the same electric charge, move further apart. So like and like repel, different objects attract. This is why repulsion is the tendency of objects that have the same electric charge to move away from each other. So if an object is positively charged and then there's another object that is positively charged, they are not going to be attracted to each other. They are going to repel each other because their charges are the same. They are going to repel each other because their charges are the same, so they move away from each other. So electrostatic charges are best obtained in dry weather. When it's very dry, this is when they're best obtained. Now let's look at the attraction and repulsion that I'm talking about. Now we're saying same charges. Same charges applies to both positive and negative. So if you've got a positive charge and a positive charge, there is going to be some repulsion. They're going to move away from each other. Same as if we have a negative charge and a negative charge, they're going to move away from each other. We call this repulsion. However, they get attracted to each other if the charges are different. If the charges are different, there will be some form of attraction. They'll move towards each other. Remember, we said charged objects are capable of influencing other objects. In the case of attraction, it's because maybe the charges are different, or the other object has a neutral charge, or the other object has a neutral charge. I'm sure that is simple enough. Now let's talk about electric discharge. We mentioned it in our objectives that we're going to learn about electric discharge today. So static electricity is the build-up of electric charges on the surface of an object. So it is on the surface. Remember when I talked about the surface of my jersey, we spoke about the ruler and the soft rock. So it is on the surface of an object and usually a non-conductor of electricity. Obviously, my jersey doesn't conduct electricity. Obviously, my pen doesn't conduct electricity. Okay, so now the charges remain static on the surface. So if there's friction and then it becomes charged, the object becomes charged. So the charges remain static on the surface of the object because they are not moving. They are not moving, they are there on the surface. So when there are too many charges on the surface of an object, the charges will move to a neutral object. They'll move to a neutral object or a positive object. If there are too many of them, they're going to move. And this is called electric discharge. This is called electric discharge. That's why sometimes when you hold a doorknob, you get shocked, right? So electric discharge would have happened. The electrons would have moved, the charges would have moved from the doorknob to your hand. They would have moved from your doorknob. Remember, your hand is neutral. Your hand is neutral, and they would have moved from the doorknob to your hand. Let's look at the different materials that can actually discharge electricity if, however, they are charged. We've got glass, plastic, ceramic, rubber, wood, fabric, paper, cork, and wool. All of these are capable. So that's why sometimes just that sticks to your legs. Okay, so now let's talk more about electric discharge. So this is when there's the release of electrons through a solid, liquid, or gas. So any material in any phase is capable of releasing electrons. So discharging occurs when objects touch each other, or when one object is brought near another object without touching. So it's either they touch each other or they are at a very, very close proximity. They're very, very close to each other. So we're capable of having electric discharge in that instance. Look at this lady here. She was trying to open the door and then she got the shock of her life. Okay, so electric discharge causes this. It causes sparks. It causes shock of static electricity, especially when the air is dry. So next time you get shocked when you open a doorknob or touch any surface, just know that that surface is charged and it has just released some electrons onto you. Okay, now let's move on. So lightning is a pretty good example of electric discharge. I'm sure we've all witnessed or we've all seen lightning. There is a video of lightning, especially in the summer months when it rains a lot. So it is an example of electric discharge. So although the sparks are caused by static electricity, they are harmless. Some are harmless, but however, electric discharge can be dangerous, especially if you are struck by lightning. So we've got Polo there, And Polo has just been struck by lightning. Ooh, I'm sure he's in terrible, terrible, terrible pain. I'm sure he's in a lot of pain. So now let's move on to our second activity of the day. The first question is, how does a charged object affect another charged object? What is an electrostatic discharge? What is the result of a discharge of electrons? What will happen when you are electrically charged and if you touch your friend? And what does your friend experience when you touch him or her or them? I'll give you 5 minutes to answer these questions. Don't forget to send in your answers to 079-578-2908. Let's look at the solutions. How does a charged object affect another charged object? The reason is it can attract or repel another charged object. Remember we said like charges repel and then opposite charges attract. So that is how a charged object can affect another charged object. What is electrostatic discharge? It is the flow of electrons from a charged object to a neutral or positive object. So if electrons are moving to an object that is positively charged, we call that electric discharge. What is the result of this? What is the result of the discharge of electrons? They can be a spark or they can be a shock. They can be a spark or they can be a shock. All right. What will happen when you are electrically charged but you touch your friend? There'll be an electrical discharge to your friend. So if you are charged and you touch your friend, there can be an electrical discharge. You feel it. You feel it by feeling some kind of shock. When you feel some kind of shock, which means one of you is charged. And then what does your friend experience when you touch him or her? They'll experience a slight shock, or they might see a spark. If you happen to be in the dark, let's say there's load shedding and you're in the dark, you can see a spark. You can see a spark. Okay, so next we're going to move on to an experiment, a practical demonstration of friction and static electricity. All right, we're going to move on. So I'm going to give you a few seconds to ready yourselves, and then we do our experiment.
Attitude of gratitude. Of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful, ubonge, lebuha, be grateful each and every single day of your life. Strive to display an attitude of gratitude.
Welcome back, grade 8 learners. I'm sure you had enough time to copy down all of the corrections. So now we're going to do a short experiment, one that you can even do at home on your own. So for this experiment, the aim is to investigate friction and static electricity. So what is the hypothesis for this experiment? The hypothesis is friction between a balloon and wool causes static electricity, which causes papers or hair to stick to the side of the balloon. So what do we need? We need a balloon and pieces of paper. That's all you need. That's why I said you can do it even from the comfort of your own home. So we're going to discuss the steps that we're going to do, which is the method. How are we going to go about this experiment? So first things first, you need to take a balloon that is full of air. If it doesn't have air in it, just blow air into it. Then next, hold the balloon from a short distance from the pieces of paper or your hair, and then note down what you notice. And then next, you need to rub wool with the balloon. So you rub the balloon against the wool. And then next, you now hold the balloon a short distance away from your hair or pieces of paper, and then record what you see. So now that we've discussed the steps of the experiment, let us move on to the actual experiment. So the first step was to fill up a balloon with air. If it's not filled already, mine is already filled. And then next is to bring the balloon towards the papers and then write down what you see. Even my hair, if you've got papers or hair, and note down what you see. And then the next step is to take the balloon and rub it against wool. I'm wearing a woolen jersey, so I'm going to rub it against my arm. This one side of the balloon, rub it against my arm. And the next thing is you bring it towards the pieces of paper. What do you see? Once you bring it towards the pieces of paper, what do you see? And if you've got long hair, you can also bring hair towards it and record what you see. There we go. What do you see? What's happening between the balloon and the hair? What is happening? Alright, so now we're at the end of the practical aspect of our experiment. Next, let's go and discuss results and observations.
You have been given power to decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now with the decisions that you are currently making in your schoolwork. So decide whether you want to be an A student and start working on it, because there is power inside of you. The infinite power is inside of you, and the time you decide to tap in that power, you will become who you want to become in your schoolwork.
Welcome back. I'm sure you're going to be trying out that experiment. You can use a ruler, you can use a balloon, you can use any kind of material that is an insulator. You can use any kind of material that is an insulator. You can use pieces of paper, or you can use your hair. You can try this experiment at home. So now we are going to discuss our observations in terms of experimental questions. Remember, there were some questions in the method. So now the first one is, what do you do to make your hair or the pieces of paper stick to the balloon? What do you do? This is, you rubbed the balloon on the wool. So I'm wearing a woolen jersey. You can use any other soft cloth as well when you're doing the experiment. So what did you do? We rubbed our balloon on wool. That's what we did. The second question is, did you understand why the paper rises and is attracted to the balloon after you rub the balloon on your hair? Explain. Do you understand why the paper rises? Okay, so this is why. Because the electrons move from the atoms and molecules in your hair onto the balloon, and the electrons have a negative charge so that the balloon becomes negatively charged. So these are the observations. So the first time round, the paper didn't stick onto the balloon because both objects were not charged. They, however, became charged after we rubbed the balloon against the wall. That's when they became charged. Okay, I'm sure you enjoyed this experiment thoroughly. So now, I received 2 WhatsApp messages, one from a learner from Totolifa and another learner didn't mention their school. Thank you so much for responding. Keep on sending your responses that you are part of this lesson, to tell us you're part of this lesson. So now let's wrap up our lesson and summarize everything that we've learned today. So friction can cause the buildup of electric charges on the surface of objects. So if there's friction, it can be the cause of a buildup of charge. Now, electrons are capable of moving from one material to another, causing some materials to be negatively charged and others positively charged. This moving from one object to another. So unlike charges and attract, like charges repel. Unlike charges, negative and positive. Like charges, negative and negative, positive and positive. So unlike charges are going to attract, like charges are going to repel. Now, the discharge of electrons. The discharge of electrons can cause shocks or sparks of static electricity. So that's why sometimes your dress sticks to your legs or your clothing sticks onto your body because there has been friction, and now you are going to feel a shock when you hold that doorknob. You're going to feel a shock when you feel that doorknob. If you're in the dark, you can even see sparks. And lightning is a good example of discharge. Okay, so I've got some activities for you to do at home. Here are the questions. Grab your pen, grab your paper, and copy them down. So I'll read them to you, then give you time to copy the questions. This is homework, so you copy the questions. Explain the following concept. What is static electricity, electric charge, electric shock, electric spark, electric discharge, and then the second question is a sock. A sock falls from the washing line and clings onto a wall. Explain how this is possible, firstly, and then secondly, what makes the sock that you wear on your foot, the sock fall from the wall eventually. So 2 minutes, write down the questions quickly. All right. Now, the next lesson is going to be on circuits and current electricity. I can't wait for that lesson. Okay, so thank you so much from me. And don't forget to sanitize, wear a mask, and keep social distance. Until next time, goodbye, grade 8.